Hello everyone, and welcome to this video on identifying key influencers in social networks. In today's world, social networks play a huge role in how information spreads, whether it's news, trends, or even marketing campaigns. Everything moves through these networks of connected users. But not all users have the same influence. Some users can spread the information very quickly to a large number of people, while others may have very little impact. So, in this video, I'll explain how we can model social networks using graph theory and how algorithms like PageRank help us identify the most influential users in these networks. So, social networks such as Instagram, Twitter, and Facebook connect millions and even billions of users worldwide. Every day, people share posts, comment, like, and interact with one another. This creates a massive network of connections between users. However, one important thing to understand is that influence in these networks is not equally distributed. For example, if an average user posts something, it might only reach a small group of people. But if a well-known influencer posts the same thing, it can reach thousands or even millions within minutes. This difference in influence is extremely important in many areas. Companies rely on influencers to promote products, and platforms use influence to recommend content. And researchers study how information spreads across these networks. So the key idea here is that understanding influence is essential for analyzing social networks. This brings us to the main problem. In a large social network, there are millions of users, and clearly, not all of them are equally important when it comes to spreading information. Some users act as major hubs, spreading information very quickly, while other users might have very limited reach. The challenge is that we cannot analyze each user and determine how influential they are manually. So the question becomes, how can we systematically identify the most influential users in a network? We need a method that allows us to measure influence in a consistent and scalable way, especially when we're dealing with very large social networks. To solve this problem, we use graph theory. Graph theory allows us to represent complex systems as simple mathematical structures. In the case of social networks, we represent each user as a node, also known as a vertex, and each connection between these users as an edge. For example, if one user follows another, we represent that as an edge between them. By modeling the network as a graph, we can analyze relationships and apply algorithms to study how influence flows through the network. This approach simplifies a complex, real-world system into something that we can study and understand more easily. There are different types of graphs that we can use to represent social networks. So, in a directed graph, connections have a direction. For example, if user A follows user B, the connection goes from A to B. This is important because the relationship is not necessarily mutual. Just because user A follows B does not mean User B follows user A. In an undirected graph, connections are mutual. For example, if two users are friends, then the connection goes both ways. In most social networks nowadays, we use directed graphs because relationships like following are directional. And this is actually the basis of Instagram's social network. However, there are still undirected graphs to this day being used in social networks, such as Facebook's Friends social network. Before applying algorithms, we need to understand what makes a user influential. One obvious factor is the number of connections a user has. A user with many connections can directly reach more people. However, influence is not just about the quantity. It is also about the quality of these connections. For example, being connected to highly influential users can increase your own influence. And another important factor is acting as a bridge between different groups. Some users connect separate communities, allowing information to flow between them. So, influence is a combination of multiple factors, not just the number of connections a user has. One simple method for measuring influence is degree centrality. This method counts how many connections a user has. The more connections a user has, the more influential they are considered. This approach makes it easy to understand and easy to compute, which makes it useful as a starting point. For example, if a user is connected to many others, they can directly spread information to a larger audience. However, as we will see, this method has some important limitations. Although degree centrality is simple, it does not fully capture influence. One major issue is that not all connections are actually equally important. A user might have many connections, but those connections are not influential themselves. For example, someone could have many followers who are inactive or not well connected, which limits their actual impact. Another problem is that degree centrality does not consider the importance of users you are connected to. This means that it treats all connections as equal, which is not really realistic. So, we need a more advanced method that considers both the number and the quality of these connections. So, this leads us to the PageRank algorithm. PageRank was originally developed by Google to rank web pages based on their importance. The key idea is that a node is important if it is connected to other important nodes. In other words, influence is not just about how many connections you have, but also who you are connected to. This makes PageRank much more effective at identifying truly influential users. So, PageRank works by distributing importance across the network. Each node starts with an initial value of importance. Then, each node passes its importance to the nodes it is connected to. If a node has high importance, then it passes more influence to others. This process is repeated multiple times, allowing importance to flow through the network. And over time, the values stabilize. and we get a ranking of nodes based on their influence. This iterative method uh, allows PageRank to capture both direct and indirect influence. PageRank is calculated using a formula. The importance of nodes depends on the importance of the nodes connected to it. Each node distributes its value equally among its connections. So the formula also includes a damping factor, usually around 0.85, which represents the probability of continuing through the network rather than jumping randomly. This factor helps make the model more realistic and ensures that the algorithm converges to stable values. Um, while the formula may look complex, the key idea is actually simple. It's just about importance flows through the network. Now, let's walk through a simple example to better understand how PageRank actually works in practice. So, here we have a small network of users, A, B, C, and D. At the beginning, we assume that all users have equal importance. So, since there are four nodes, we're going to give each one of them a value of 0.25. Now, we begin distributing influence based on the connections between the nodes. Node A will receive its importance from node C, so A becomes 0.25. Node B receives its importance from node A, so it also becomes 0.25. Node C receives importance from two nodes, B and D, so it will get 0.25 plus 0.25, which is zero point 0.5. And lastly, we have node D, and it has no incoming connections, so it receives no influence and becomes 0. So after this one iteration, we can already see that node C becomes the most important node in this network. This happens because it receives influence from multiple nodes, while others receive influence from fewer nodes. If we repeat this process multiple times, the values will continue to update until they stabilize, giving us the final ranking of nodes based on their influence. This example shows how PageRank captures both direct and indirect influence, making it more effective than simple methods like degree centrality. PageRank and similar algorithms have many real-world applications. They are used to identify influencers in social media, as we've seen, which helps companies target the right users for marketing campaigns. They improve recommendation systems by identifying important users and content. They are also used in network analysis to detect important nodes in communication and transportation systems. And most famously, PageRank was developed and used by Google to rank web pages in search results, which revolutionized how search engines work. So, to summarize, we started by modeling social networks as graphs. We saw that not all users are equally influential, and we explored degree centrality as a simple method, which we discovered has its limitations. And then finally, we introduced PageRank, which provides a more accurate way to measure influence by considering the importance of connections. This shows how graph theory can be used to solve real-world problems. I hope this video helped you understand how algorithms like PageRank can be used to identify key influencers in social networks. Thank you so much for watching, and that will be all for this video.